Hey everybody, Mr. Piercy here, talking a little bit more about lines today. So what we've been talking about so far with lines was lines with transversal lines and the angle pairs that are created and what happens when those lines are parallel to each other to the angle measurements and vice versa with the converses. Well, today we're going to go a little bit back in time. We're going to be talking about slopes of lines. We're going to be talking about how you find the slope of a line and what they mean as far as uh, when to tell if the lines are parallel or perpendicular based on their slope. So here, slope is, this is more of a description more than a proper definition, I would say, but it's a ratio of the vertical change to the horizontal change, essentially rise and run, the change in y over the change in x. And really, if you ask me, uh, what would be considered a good definition of slope? If I ask a student, well, what is slope? If a student could really just tell me that, rise over run, I would actually be pretty happy with it until I ask you, well, do you know what the formula for slope is? And if you could tell me that, then that would be even better. We'll get to that here soon in just a minute. So looking at the diagram that you have right underneath there where it says slopes of lines in the coordinate plane, positive and negative slopes are pretty good. Kids are really good at identifying when something is positive or negative because this is one of the few things in math where we typically look at it strictly from left to right. A lot of things in math can be looked at in both directions. I can look at it from left to right, or I can look at it from right to left. Lots of equations, graphs, inequalities can be read that way and not lose any integrity or not lose their meaning. Well, when it comes to graphs, because a lot of times we're looking at them in respect to where it is on the number line, particularly the x-axis, as you go from left to right on the number line, that's when things are increasing. So that's why we think of that as positive, not just because the numbers work out to be positive when we do the slope. Same thing with negative. If you're looking from right to left, that's where you're headed towards the negative side of the x-axis. So that's also, I would say, just looking at it, why it's falling. So that's why those two particular lines are identified as positive and negative, respectively. So the undefined slope. Now, this is one that generally is going to cause kids to have some struggles. An undefined slope is when, generally speaking, anything that we call in math as something is undefined. It's really when I have something where I'm trying to divide by zero. That's really where we're going to say something is undefined. And that's also going to produce a vertical line where it'll pretty much be the only equation where we say x is equal to, I don't know, some number, let's say 6, I don't know. That's about the only equation where we're really going to see, the only time where we see the equation say x is equal to something as opposed to y is equal to something. Now there's a little bit of nomenclature that can be tricky. What is no slope and what is zero slope? Some people think that they're the same, meaning if I say that there's no slope, then it has a slope of 0. And other people have the mindset of that if I say that there's no slope, then it must be undefined. I find the whole thing relatively tricky because I see both points of view when somebody says I have an undefined slope if I have no slope, or if I have 0 slope if I have no slope. So for the purposes of my explanations, I will strictly refer to 0 or undefined, meaning a horizontal line or something like that. Now, 0 slope, this is a thing that kind of boggles kids a little bit. Whenever we are doing the slope formula, here if I say 0 over 5, 0 over 5 is fine. 0 divided by 5 is nothing. I can't put something into nothing. But trying to divide by 0 is going to cause the world to stop spinning on its axis and can't be done. That's why we call it undefined. And that's going to give us a horizontal line where it'll say y is equal to some number, whatever that number is. So keep in mind, particularly with these, the graphs, or when you're doing slope, if it's a 0 on top, that's fine. You can say 0 divided by something is 0. If the 0 is in the denominator, no such luck. That's considered undefined. So one of the things that I will kind of expect my students to do is practice good fundamental math skills. Anybody that's in any kind of an extracurricular, band, choir, orchestra, drill team, ROTC, any kind of athletic, swimming, football, basketball, your coaches, your mentors, your trainers, in some way they're going to emphasize practicing fundamental skills, because if you have good fundamentals, then you have good foundations with which to build on. And it just happens to be, ladies and gentlemen, that I really think a good fundamental practice is anytime that you use a formula, you write it down. Particularly, well, let me clear that off because I'm really looking more just at this. Here is the formula for slope. So generally speaking, if I'm going to ask you to find the slope of a line between two given points, I will expect you to show me what formula that you're using. This is something I've been doing since I was in school. I've been teaching for a lot longer than you've been a student, and this is something that I still do anytime I use a formula. Every time I use a formula, I always write it down. Uh, doesn't really make a difference what the formula is, how many times I've used it, how familiar I am with it. If I have to write it down on a piece of paper, I'm going to write down the formula, and then I'm going to start substituting my numbers. So start getting into the habit of that. So here, our notes aren't going to do a great job of always using the slope formula, so I'll try to put it there where I can. But slope formula, y2 minus y1 over x2 minus x1, change in y over the change in x. So looking at the examples that we have here, find the slope of line A and the slope of line C. So again, what I would do is I would start by writing the formula, then I would start by substituting the numbers, because we have a choice. We have to choose which one is 0.1 and which one is 0.2 on line A. So they kind of arbitrarily chose 0.46 to be the second point. So that means 0.02 would have to be considered the first point. So you take the difference of the x and the y numbers, and you get a slope of 1 when you simplify the fraction. Now, just as a quick, sometimes this is things I take for granted. If you have a fraction that you can simplify, you must simplify your fractions, okay? This is just kind of something that I seem to take for granted as a teacher. So for instance, let's say you're working out slope, and it works out to be, I don't know, 6 over 8. I would not accept 6 over 8 as an answer unless you simplified it to be 3/4. Okay, just keep that in mind. If you can simplify a fraction, I will expect you to simplify it. So now let's take a look at the line C. They're using, since line A and line C both intersect at the same coordinate, they're just kind of arbitrarily saying, well, 0.46 is going to be the first point again, so 0.06. I'm sorry, I said that backwards. 0.46 would be the second point, so that means 0.6 on line C is going to be considered the first point in the formula. So here, this is where we see the 0 over the 4. So having a 0 in the numerator is okay. That means we have a 0 slope, okay? And we just say the slope of the line is 0. So here, what you're seeing at the bottom, at the checkpoint, line B and line D, go ahead and use the slope formula. Find the slope of those two remaining lines, and after you find the slope, come back, hit play on the video again, and see how you did. See if you agree with my answers. So go ahead and hit pause now. Come back when you're ready. All right. So hopefully you have your slope for line B and line D. So again, anytime I use a formula, I am going to write it down. So y2 minus y1 over x2 minus x1. Now here, they're kind of giving me a choice. I have the choice to call which one I want to have as 0.1 and 0.2. So I decided to make 7 and 3 the second point and 4, 6 the first point. And when you do the math, we get negative 3 over 3. Simplifies to be a slope of negative 1. And for line D, there we go. Substitute your numbers. 0 minus 6 gives you negative 6 in the numerator. 4 minus 4 gives you 0 in the denominator. And this is where we run into a problem. I do see a lot of students, when they have a 0 in the denominator, want to say that the slope is 0. Especially because if they type it into the calculator, it comes back with that error, and they're not sure what that means exactly. Well, that's the calculator telling you that it's undefined. So if the 0 is in the denominator, we call that one undefined. Okay, so moving on, let's see what we have next. Here we're moving on to some more postulates. Now, again, keep in mind, postulate 17, postulate 18, that's not a real name for a postulate. You can't pick up any geometry textbook and look up postulate 17 and have it say this. This is simply the 17th and 18th postulates, respectively, that we might have seen in this particular curriculum. But here it's a postulate of slope of parallel lines. Now remember, postulate is something you can kind of accept to be true. So yes, if lines are parallel to each other, I can accept the fact that they are going to have the same slope. And if I have horizontal or vertical lines, those are parallel to each other. So horizontal lines obviously will have a slope of 0. And undefined lines, or vertical lines, even though they don't technically have a value of their slope, it's undefined. Because they're all vertical, they must be parallel to each other. And so here, this one, I'm not sure if I would exactly think of it as a postulate. I think this is kind of something I would have to have explained to me, see it a few times, use a little bit of inductive reasoning. But I'm splitting hairs, and I would say, yes, I can accept that if I have slopes whose product is -1, those are going to produce perpendicular lines. Now here, what I want to point out to you just real quickly on the side, here where they're saying they're negative reciprocals, maybe your algebra teacher referred to them as negative reciprocals, maybe they refer to them as opposite reciprocals. I kind of lean towards saying opposite reciprocals, but that's just me. It's just a personal preference. If you say opposite reciprocals or negative reciprocals, same thing. So, but just keep in mind, here the text is giving us negative reciprocals, but you'll probably hear me refer to it as opposite reciprocals. Now here, can you identify parallel lines? Now one of the things, let me just kind of use this as a talking point. One of the things that I mentioned, or that I noticed in some of the homework assignments from this, is that students were misidentifying lines to be parallel to each other. For instance, we might have had a diagram that kind of looked a little bit like this, where this one had an arrow and this one had an arrow. And let's just say this is A, this is B, this is C. A lot of students, when asked to identify what lines are parallel to each other, told me that line A and line B were parallel to each other. And unfortunately, that was not correct, because there's nothing marked on the diagrams showing that they are parallel. Even though they're drawn to look very similar to each other, very parallel to each other, they're not marked that way, so we can't say that they're marked that way. Now here, none of the lines are marked that way, and that's fine. Because they're giving us coordinates with which to work, we can figure out, well, what are their slopes, and figure out what the slopes of those lines mean based on the postulates that we just saw. So here I'm finding the slope of line K sub 1. Maybe you want to think of that as line A if you want to, but we're going to find the slope of that guy, plugging in the numbers. Now, again, here's the formula. I don't have space to write it out each and every time, but here's the formula again. And we get that slope to be a slope of positive 5. So moving on to K sub 2, when I plug the numbers into the slope formula here, I get a slope of 6. So based on that, we would say, well, those two lines, K1 and K2, they're not parallel to each other because they don't have the same slope. And you kind of gave it away here. I guess I forgot to tell the 5 to disappear until I told it to come out. But when I find the slope of the third line, K3, we get another slope of 5. So when I compare the three values of slope that we have here, 5, 6, and 5, respectively, for the three lines, Well, what we would be able to say that K1 and K3, because they have the same slope, those two lines must be parallel to each other. Well, since K2 is not, it's a different number. It doesn't matter what that number is. It's a different number, so it cannot be parallel to each other to the other lines. We would say they'd probably just intersect at some point. So what I want you guys to do here, I think we kind of know where this is headed. Go ahead and pause the video and answer the third question here, the checkpoint question. And when you're done, come back and check to see how your answer compares to mine. All right, so I'm going to again presume that you've worked through everything that I've asked you to work through, and you're not just keeping the video on play and working through to see what answer I come up with. So here, looking at the slope of the line, we're going to say, well, the slope of line C happens to be 3. And so that's kind of what I'm saying here. And that little lowercase m is representing slope, obviously. So I'm saying this is how I denote the fact that I'm talking about the slope of line C. M sub C is the slope of line C. So we have a slope of 3 on that one. And let's see, there's my other one. So here now we say the slope of line D has a slope of -3. So are these two lines parallel to each other? Well, clearly they cannot be parallel. The absolute value of the numbers is the same. The absolute value of 3 is 3, and the absolute value of -3 is 3 also. But we're not asked about the absolute value of the numbers. Are the actual slopes the same? +3 and -3 are very different numbers, so they are not parallel to each other. Are they perpendicular to each other? No, they're not perpendicular either, because even though one is positive and one is negative, they're opposites of each other. They're not reciprocals of each other. So, moving on. Now we want to see, can we draw a set of perpendicular lines? Now, again, keep in mind, the way that we tell when something is perpendicular is that the slopes have to be opposite reciprocals. So if the slope of one line is, say, like, let's say the slope of, oh, if I have my pen turned back on. Let's say the slope of one line is, I don't know, 2/3. Well, if the slope of the second line has to be perpendicular to it, well, then it would have to be a -3/2, opposite reciprocals. So here we have line H. It's going to pass through the 2 points that they're giving us, and we want to graph a line that's perpendicular to it, but it has to go through the point 2,5. Well, the first thing I want to know, what is the slope of line H? And this is going to be a pretty typical thing. And a lot of this hopefully is really ringing a bell from things that you did in Algebra 1. See whether they're parallel or perpendicular to each other, or neither. So looking at the points that they give us for line H, I'm going to say, well, the slope of that line has a slope of 2. And so that means if the slope of line 1 is a +2, then working it out using the formula here, since the product of the two numbers has to equal -1, then that means the slope of that line has to be -1/2. Now you don't actually have to do the math for that, but that's how you would do it. If you were doing the math, you can just look at it and say, oh, it'd be -1/2. Because you can just kind of in your head understand opposite reciprocals, what is, one's positive, one's negative, and what's the reciprocal? You turn the number upside down. So here, this is what the graph of the line would look like. So the line that the positive line obviously is going to be line H, because that's the one that has the slope of +2. And then the second line, the negative line, that's going to be the perpendicular line, and it clearly goes through the point that we identified right there as being +2,5. So there we go. There is how we're going to graph those lines. Look at the slope of one, figure out what its opposite reciprocal is, and just plot some points. Just draw it with a straight edge. See what you get. Now this example here is not my favorite example in the world. I'm going to be fair and say it's not my favorite example. This is really really just asking you to see, can you understand the meaning of the slope on a graph? Not necessarily is something parallel or perpendicular to each other. So here we're kind of looking at slope as a rate of change and using that rate of change to make an interpretation about something. So here they're talking about the truck driver being represented, their slope, and the segments A and C, because they have the same slope, well, they're parallel to each other. That means it took the same amount of time, or they were driven at the same rate. Okay, not the most glamorous use of interpreting slopes and rate of change and what they could actually do, especially as parallel and perpendicular are concerned. But it is what it is. Not a bad exercise, just not necessarily the most glamorous one I've ever seen. So here we go. This is where you guys are going to start taking over. Question number 4 is pretty much we're just looking at slope to see are the lines parallel, perpendicular, or neither. And 5, you're going to go back and look at the diagram that we just looked at to make another interpretation. So go ahead and pause the video here, answer these 2 questions. When you're done, come back. All right, guys. So hopefully you are doing what we asked you to do here. So here, line 4, what we're going to be doing, line in passes through these 2 points, line in passes through these 2 points, so their slopes respectively are -2/7 and +7/2. Well, those do very fit, pardon me, those very much fit the definition of perpendicular lines having opposite reciprocal slopes. So yes, I would say those lines are perpendicular to each other. Example number 4, which delivery is the fastest rate of travel? Clearly delivery B, because it has the fastest rate of change. And that's pretty much it for this lesson. What we're primarily doing again, do you remember what slope is? Do you remember how to calculate it? Can you determine by looking at the values of slopes when something is parallel, perpendicular, or neither? And that last little bit there, can you interpret it based off of a graph when we give it some kind of an application purpose? So as always, ladies and gentlemen, any questions, thoughts you might have, make sure you write them down as we go. Let me know what they are in the comment section of the class. Until next time, guys, thanks for watching and take care of each other. See you soon.